What we need to look at next with chords is some properties dealing with chords and segments. The last one was looking at chords and angles, and this one is chords and segments, so other lines within the circle. Again, these two theorems are on your student note sheet if you're using that. Otherwise, make sure you do get them written down in your notes. These theorems are really important. So the first theorem that we see here on this page states that if chords are equidistant, right, the same distance, you'll see that these are showing that they're the same distance from the center, then they will be congruent. And so if they're the same distance, then they're the same length. And it has to be the distance from the center. So when we look at this first diagram, if SF, if this distance is congruent to SE, which is this distance, then these chords, CD and AB, have to be congruent. They're going to be the same length. The next one says that if a diameter is perpendicular to a chord, then it bisects it. So no matter where it is on the circle, if your diameter is perpendicular, then it's getting bisected. Those two parts of the chord have to be equal. So when we look at this diagram, if length CD is a diameter and CD is perpendicular to AB, then these two pieces, so BE, must be congruent to AE. So we're going to look at a couple of practice problems with these properties of chords. So this first one here is looking, you have two circles, and we're working on trying to find some other lengths. And so this first one here, we're trying to find this X. Now this property is dealing with, we have a length that is perpendicular, right? This line could keep going in both directions, but the really important part is it's coming from the center and it's perpendicular, which means that these two parts have to be the same. Well, if 1/2 is 6, then this X has to also be equal to 6. So if we look at this next one, if we want to find this X value, well, we know that this line that is going through our center is perpendicular, which means that these two parts have to be the same. And so if that's true, then X is going to be equal to 3. Okay, so that's one of the properties that we could look at. Now this next one, we're given some information. We know that we have a chord that is perpendicular to the center. We know that it's 4.6 away. If it's perpendicular, remember that we know that those are equal, right? Which means this half is 2 and this half is 2. Now what they want to know is they want to know the radius. Something really important to remember with the radius is that it doesn't matter where I draw this radius. They're all going to be the same length, right? From that center to the outside. So for a moment, I'm going to put it right here. And notice that now I've made a triangle. And I have a leg that's 2. I have a leg that's 4.6. And I'm trying to find this hypotenuse. And this is where that Pythagorean theorem is going to come back. So we want to solve for X. We want to find this radius. So we can use those properties, those theorems. And we know that one leg is 2. We know that the other leg is 4.6, and we're trying to find that hypotenuse. So let's find 4.6 squared, which is 21.16. So if I want to find the length of that radius, I'm going to take the square root, and I will find that our length x is equal to approximately 5.01597, right? And depending on where we round it, we might have different numbers. So if I want to round it to the nearest hundredth, remember I need to look at my next number here. And because that's 5 or bigger, I'm going to round up. So my answer would be x is equal to 5.02. Right, and I can use those properties and my Pythagorean to find the length of my radius. Let's look at one more together. So we have a circle. We know that this length here is 8, and this length is 8. Remember that if they are the same distance, then the chords are the same length. The other thing we know is that if this line hits the chord perpendicularly, that it's always bisected. So we know that these two halves also must be the same. So if that side is 15, then this side is 15. And likewise, we know that then these two have to be 15. So now if we want to find JM is this length here, JM is going to be 30. And if we want to find NM, we're going to have to use our Pythagorean. So we have 8 squared plus 15 squared is equal to x squared. So as we put those together, and then as I find the square root of 289, I find that x is equal to 17. So this length right here is 17. So we can use these properties in addition to Pythagorean theorem and solve for some missing pieces. What I want you to do is send me a message in the chat with that number of how you feel your understanding is. From a 0 to a 5, how are you feeling about these properties dealing with chords inside a circle?